So we saw that the top four layers are taken care by the operating system. It may be Linux or Windows. So those four layers are not our responsible.
Mm-hmm.
It's under the control of operating system. We don't decide the port number. It does not meaning that we cannot change the port number, but usually on the host we don't do it. But
Mm-hmm.
on the routing devices, sometimes we do port forwarding. Means any packet coming to 8080 should be forwarded to port number 80. You know, so any packet coming to 8043 should be forwarded to 443. See, that is
Mm-hmm.
to that is to avoid using the default port number. We take some unreserved port number and we map it to a reserved port number so that if an attacker uses port number 80 to attack us, they cannot because our edge device is not responding to 80, it responds only to 8080.
Mm-hmm.
We call this port forwarding. Anyway, we that's too far for like CCIE level. We are not into that now.
Mm-hmm.
We we here understand that we have nothing to do like a configuration to tune this first four layers. Operating system is in control. Now we are going to go in depth on first all this first four, and then we'll go to the remaining three. Application
Okay.
layer, as we saw, it is responsible for providing an environment where we can send and receive data as per our desired format. I want a mail,
Mm-hmm.
so it's a mail format. I want
Mm-hmm.
a document, it's a document format. So we are not having same type of network traffic. We have different type
Mm-hmm.
of network traffics. We generate different type of network traffic. We receive different type of network traffic.
Mm-hmm.
Some traffics are voice, some traffics are video, some traffics are PDF file, some traffics are documents, some traffics are for our exe file. We get different type of traffic, and we also send different type of traffic. So for those traffic to be handled, we have different type of application
Mm-hmm.
that interacts with the network. And to handle this different type of file, there is different protocol involved in this applications. Not the same
Mm-hmm.
protocol that works to send and receive mail can be used to send a file.
Mm-hmm.
That protocol picking, protocol selection that makes the network to understand what you are trying to send and receive
Mm-hmm.
is what presentation layer does. See, the word very clearly says, I'm presenting to the network. So the network will understand that the user is sending a PDF.
Mm-hmm.
The network will understand the user is sending a HTTP file.
Mm-hmm.
So someone needs to tell the network in a network understandable language from the human understandable
Mm-hmm.
language. That's the job
Mm-hmm.
of the presentation layer. That is why it is named as presentation layer. It encodes in such a way that the network will understand the variation between the difference between the PDF that I'm sending and the document that I'm sending. Only when the network knows it, the receiving device will also know to differentiate it.
Uh-huh.
Fine. So that's the role of the application layer and the presentation layer.
Mm-hmm.
Thirdly comes the session layer. As the word says, time, session, you know. This layer takes the responsibility of setting time frames for different traffics that want to leave the device and get into the device. So there should be
Mhm.
someone who needs to take care of the time. Otherwise, if two process try to utilize the network, if two different traffic tries to utilize the network at the same time, then no one is going to use the network. There should be some order. There should
Mhm.
be some sequence. For
Mhm.
for getting sequence, what you need is type. Okay,
Mhm.
this 7 o'clock you go, 7-1 you go, 7-2 you go. Someone needs to uh, sequence them and give them a time frame so that they go one after the other without disturbing others. Like
So, for
mm,
example, if we take an HTTPS traffic on a web browser that is outside of our network, so still it has a time frame
yeah,
set.
correct. you know so there's a long process involved in getting a web page for you. When you type www.yahoo.com, it is not just one packet going and saying, hi, Yahoo, come on, let's see, let me see your page, show me. No, it's not like that. There are around 11 steps involved, and for each negotiation going in between, there is a time frame. And
Mhm.
if the response don't come on time, it's going to say
Mhm.
timeout.
Mhm.
So not only a time frame is set for sending the packet out, the packet when it is sent out within this time, the response should come. I cannot wait so long. So if you come this within this time, I'm going to say the user, ah, mm, good, everything is going good. If you come delay, then I'm going to tell the user page cannot be displayed, request time note,
Mhm.
something like that.
Mhm.
you know so it is all because of the time frame.
Okay.
If the time is not there, then you will not
Mhm.
get page cannot be displayed. You'll be waiting. It will be rounding, buffering.
Mhm.
But the problem, you don't know that he is not responding.
Mhm.
The responder is keeping mum. That's why it is rounding. So you never see that. Most of the time it will say page cannot be displayed immediately. The reason is everything works with a time.
Mhm.
You ping. When you ping, either you get reply
Mhm.
or destination host
Request.
retrieval or
Uh-huh.
request timed out.
Yeah.
It is not simply making you to wait. It's not going to do that because, there's a time for the request and the response. If the
Okay.
response don't come on time, then it's going to tell you request timed out. Who takes care of those things? Session layer.
Mhm.
Another example, you are downloading and it shows
Mhm.
estimated time 56 minutes.
Yes.
How it knows it will be finished in 56 minutes? It knows the size of the file and it knows how many packets
Got
go
it.
in within
Mhm.
how many micro millisecond the packet is
Mhm.
coming back, the reply is coming back, and it calculates and gives you an estimated time.
Mhm.
All this is because of session layer.
Okay.
And it is the same session layer which is also preventing two different flow of traffic getting collide. It prevents them
Mhm.
getting collide, means going and consuming, trying to consume the resource at the same time. And that will be a problem. Like when you want to meet someone, they give an appointment. Okay, you come at this time. Why?
Mhm.
Because you will have a lot of visitors to come daily, and they do not want everyone to come at 8 o'clock and sit outside in the reception. So he provides a time frame for each people who want to visit, so that we go between that exact time, so that we also no need to wait for long. Session is time frame. Next.
So, for example, we give multiple HTTPS session at the
Mm,
same time we
mm,
download,
mm.
and all of those takes place simultaneously, right?
They do happen simultaneously for you. For your
Mm-hmm.
eyes, it appears like that. But
Mm-hmm.
they have gone out with a request in a different millisecond out
Mm-hmm.
and
Mm-hmm.
different millisecond in happened. And it
Okay.
appears for you that all the pages are opening at the same time. Now, for human being, yes, it will appear like that. But behind, if you see, there's a micro millisecond differences between they using the network. They're not going to use the network at the same time. Not possible.
Mm-hmm.
The operating systems never uh, go without a discipline or an order. It has an order. It has a discipline. It maintains time for every frame.
Okay.
For you, it will appear like as if it is coming up at the same time. I opened Yahoo in one web browser. I opened Google at one browser. It loads at the same time. No, it is not exactly.
Okay.
Uh, for our eyes, it appears like that, and they come in a lot of small packets, and they get assembled here. So you will not
Mm-hmm.
know the difference, but they do have different time period. um, it's not like the fur. Okay, you may think like, then Yahoo should completely load till that time. Google should wait. No, it's not like that.
Mm-hmm.
Your
Okay.
request and response goes in many pieces. First piece of
Okay.
Yahoo has gone, second piece of Google is going. Sorry, first piece of Yahoo has gone, now the first piece of Google is going. Second piece of Yahoo has gone, Yahoo request has gone, now Google request is going, the second piece of Google request. You know, so
Okay.
they 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 work, though they work together, they don't clash because they got different session. No.
Mm-hmm.
Next is, again, you're not going to take care of this. This is being controlled by the operating system. After the time frame is given for a traffic to leave and for the response to come back, um, the big data now needs to be sent over the network within the time frame without any difficulty.
Mm-hmm.
So, how do we manage to carry 100 kg of sugar when there are four people with us? What we do is we try to
Divide.
divide that 100 kilogram into 25 bag each, and we give it. Or if there is one grown up guy and one middle aged guy, when I say grown up, he's like around 35, healthy, strong,
Mm-hmm.
and there's another guy who is very weak, like 14 years, 12 years between,
Mm-hmm.
and there is one another child around 6 years, and you are there maybe 30. Now you don't divide that 100 kg equally
Mm-hmm.
according to their capacity.
Mm-hmm.
You divide those 100 kg
Mm-hmm.
and give it to and carry all four of you. Same way, according to the capacity of the media which is going to carry this traffic,
Mm-hmm.
the big data need to be now segmented. Need to
Mm-hmm.
be broken into pieces
Okay.
and then sent out. Um, Before that, the pieces need to be sequenced. Someone should know, the receiver should know that, oh, this is the first piece of the data and this is the second piece. So when they rejoin it, they will know the sequence in which they need to rejoin the data which is broken there. Because when we break the packets and send to Okay, let's say you ordered for a product, a very huge product, and they say we cannot ship it in one box.
Mm-hmm.
We are shipping it in multiple boxes and
Mm-hmm.
through multiple carriers, through multiple shipping company.
Okay.
So how do you know which one goes first and which one goes next when you install it? So they have to number it.
Yeah.
When they number the box, then you know, okay, this is the first box I should open and set it, and this is the second box I need to open and connect it to those things which I took it from the first box. That's how you can assemble and get a beautiful robot that can cook
Mm-hmm.
for you, can wash for you. So the assembling of robot, which came in pieces from a company through various shipping company to you, happens easily. It happens. It is possible easily to assemble only when it is properly sequenced.
Mm-hmm.
Otherwise, we may we may not know which goes because the robot the company very clearly say, hey, it's not in a structure of human, it is in a structure of something which you don't know. It is not in a structure of dinosaur or a horse or a human.
Mm-hmm.
So we cannot explain you how it will look like. So better follow the order. Take the first box, keep it ready. Take the second box, connect it. Third, connect it. Fourth box, connect it. Now you get the complete robot.
Yes.
If they have not numbered it,
Mm-hmm.
assembling is not possible. Same way.
Okay.
The transport layer for the easy transportation. See, that's why it is called as transport layer. In order to transport it very easily,
Mm-hmm.
we segment it.
Mm-hmm.
The operating system segments it for the
Okay.
easy transportation. That is why it is called as transport layer. According to the
Is that a particular size
I say
that
no,
the
according to the capacity
okay.
for a 6-year-old child, for a
Okay.
35-year-old child, 30 adults and 30 and 17, I said, right? According to the
Mm-hmm.
capacity.
Okay.
According to the fiber optics or ether standard,
Mm-hmm.
according to their the, the the capacity,
Okay.
the segmentation happens here. The
Okay.
transport layer segments it and sequences it, and then after sequencing, it will send,
Mm-hmm.
and it will go in various paths.
Mm-hmm.
If you have multiple paths to reach the destination, it goes by taking various paths. At last, it goes to the destination, but it is not going in sequence actually. Maybe the fourth
Mm-hmm.
packet goes early, and
Mm-hmm.
then the second packet, and then the third packet, and then the first packet. So the sequence here helps the receiver to wait for the complete set of data to come. Once it
Mm-hmm.
receives the beginning and the end file,
Mm-hmm.
it
Mm-hmm.
starts rearranging.
Okay.
That is the job of transportation layer. It is not only sending, it is also receiving responsibility for this layer.
Mm-hmm.
Both sending and receiving responsibility.
Mm-hmm.
Now, next is this transport layer takes care of transportation as we saw now. It is also responsible for telling the receiver what exactly this packet is looking for in their
Mm-hmm.
in their means in the
By
destination.
using the port number.
Yeah. So transportation layer also provides the service ID. What service
Mm-hmm.
am I looking for? I'm looking for HTTP page. Okay. How do I
Mm-hmm.
tell that I need HTTP service, I say 80. When I
Mm-hmm.
say TCP 80, every operating system as per the standard they are designed. So because they all followed the same standard, every operating system, whether it is Linux or Windows or Ubuntu or anything in this world, is designed as per the standard. So when we when we get the boarding pass, we know the standard, the size of the boarding pass. We know when we flip the boarding pass, there should be a tag which is matching with my baggage, which I checked in. There is a standard, whether it is Lufthansa or Emirates, the standard remains the same.
Mm-hmm.
Likewise, in transportation, in transport layer, when a computer is marking with 80 as the service number, which also called as port number, actually it identifies the service.
Mm-hmm.
A logical port that is there on the destination to provide you HTTP service.
Mm-hmm.
If it is said as a service number, it will be more easy to understand than saying it's a port number. That's why I tried avoiding initially to use the word port number. Service number. When we say port
Mm-hmm.
number, sometimes it means switch port F00.
Mm-hmm.
As a beginner, people get always confused when we say port number. That's not the right way to say. Service
Okay.
ID. Service ID. How do you identify HTTP services? 80.
Mm-hmm.
How do you how do you identify Telnet? 23. How do you identify HTTPS? 443. For every service DNS, 53. You know, every service there is a number. With the
Mm-hmm.
number, when we speak to the destination understands what we need. Okay. Now,
Mm-hmm.
it is the responsibility of the sender transport layer to put the right number so that the receiving transport layer will know what I am expecting from the receiver. That
Okay.
is also taken care by the transport layer.
Mm-hmm.
So transport layer is going to provide, if a traffic is generating from A computer going to B computer. Now the A computer is going to put a random port number, let's say 5555, and because A is telnetting to B, it is going to put the destination port number as 23.
Mm-hmm.
And now the packet may go in multiple pieces, and B receives it, B assembles it, and then it finds the destination port number 23.
Mm-hmm.
And if 23 service is enabled, that is what people
Mm-hmm.
used to say, if the port is open, if the
Mm-hmm.
service is available, enabled, that's the actual term that we should use. It's not
Mm-hmm.
simply complicating someone who enters into networking as a beginner when the port is open. What port? I don't know why they made it more so complicated. When a service 23 is requested, means when a telnet service is requested, if the telnet service is open, now B will respond to the same port numbers, but it will be like this. When B responds, the source port number is going to be 23 because 23 telnet
Yeah.
is what responding, and it will
Mm-hmm.
exactly use that
Send the same
sender's source port number as the destination now,
destination.
so that when packet comes with the destination 5555, it knows to whom it has to give, to which application on the top it has to give. There are various
Mm-hmm.
applications that is open. You're parallelly telnetting SSH, you are parallelly HTTP. Now, which application generated 5555? It's the telnet application. So it goes
Mm-hmm.
exactly to the right telnet application as
Application.
the response. So the port numbers, the service identification number is also provided along with the sequencing and segmenting as per the media capacity in this transport layer. Now, there is another responsibility the transport layer has got. What is it? It decides whether to use uh,
TCP or
a
UDP.
connection orient TCP or UDP. Transport layer is going to decide whether I'm going to use TCP or UDP. For example, if you're if you're if we are sending something very much valuable in courier,
Mm-hmm.
we want to know that it is reached properly
Mm-hmm.
to the other side. So here our intention is not how quickly it reaches there. Our concern is not how quickly the packet reaches there, the parcel that I send reaches there. My concern is how safely it goes there, meaning no one should steal in the path.
Mm-hmm.
And it should go to the right person to whom I send. My concern is it should go to the right person. I'm not worried about how soon he gets it. I want him to get it. That's the main expectation. I want him to get it, even if it is late. I have no problem. I want a guaranteed delivery.
Mm-hmm.
There is another. There is another situation where I don't care whether he gets or not. My job is to send. Boom,
Mm-hmm.
I sent it. I don't care whether he receives or not. This is another approach of sending a courier.
Mm-hmm.
Likewise, in networking, some applications they want very fast communication. They cannot wait for the receiver to say, "Oh, thank you so much. I got your first packet."
Mm-hmm.
No, they don't want that because it's a voice traffic like what we are having now. It's a video traffic like what I have shared on you on the screen. The screen sharing is a video traffic and voice traffic. They are time sensitive. In between every packet, they cannot wait for the acknowledgement from the receiver.
Mm-hmm.
If that is the case, then my voice will not be continuously heard by you. My screen
Mm-hmm.
will not be seen on your screen continuously. There will be a lot of break in both video as well as audio.
Mm-hmm.
This time sensitive traffic needs immediate flashing flashing update, I can say. It should be like a triggered flow of
Mm-hmm.
data. Cannot
Okay.
be like, 5 packets send, wait for acknowledgement, another 5 packets send. No, not permitted, not acceptable when we send voice and video traffic. It's a streaming traffic. In that
Mm-hmm.
case, the applications are designed to use UDP. The application layer, the application that you picked up, they are inbuilt. That software is constructed to use UDP as a protocol in the transport layer. So it is going to come and use UDP, not the
Mm-hmm.
TCP. Whereas when we try to telnet or when we try to get a web page, in all those cases, it is not time sensitive because the network is having enough of bandwidth.
Mm-hmm.
It will open the traffic. Sorry, it will open the page that you want seamlessly There is an
Mm-hmm.
acknowledgement happening. Though there is a break in between the conversations, you will not be able to figure out that there is a break
Mm-hmm.
in such services. Those applications like HTTP browser,
Mm-hmm.
they don't really use UDP, they want only the reliable communication TCP.
Mm-hmm.
So earlier I was telling that there are 11 different conversations that happens in between your computer and the Yahoo server when you request for Yahoo page, in which three conversations are TCP connection oriented
Mm-hmm.
establishment. TCP tries to establish connection with the Yahoo server from your laptop by sending three-way handshake,
Mm-hmm.
three different packets,
Sync, and
hmm,
ACK.
which we call it as connection oriented.
Mm-hmm.
TCP is connection oriented. It sends a synchronization packet
Mm-hmm.
with no acknowledgement because this is the first packet going from A. No
Mm-hmm.
acknowledgement field. Only the sync field is having some sequence number,
Mm-hmm.
and then the B receives it, and B, if it is in a position to respond back, B fills the acknowledgement number using the
Mm-hmm.
sync number that came in, and this acknowledgement number is going to be a forwarding acknowledgement.
Mm-hmm.
For example, if A sends with the sequence number 10, B is going to put acknowledgement 11,
Mm-hmm.
saying indirectly what it
Received
does
it.
says, I got your 10, let me have
Mm-hmm.
your 11. So when A
Mm-hmm.
receives that acknowledgement, A understands, oh, he understands me. He got the 10. That's why he's asking for
Mm-hmm.
11. So not only that, B also puts its own sequence number and sends to A, and A will send an acknowledgement that completes the three-way handshake. So both A and B knows that we can understand each other very well
Okay.
because they responded with the right acknowledgement number for the sequence number.
Mm-hmm.
This is connection oriented. This happens every now and then, not for every packet, every now and then when there is a flow.
Mm-hmm.
When you are sending big amount of traffic like 2 GB or 100 Mbps, that doesn't matter. Uh, every now and then TCP will do this.
Mm-hmm.
It will go and check whether I'm still connected. Not just the first time it does the three-way handshake and then it gets you the web page. No, it gets you the web page and then it keeps on. It will keep on sending the the TCP sync packet and
Mm-hmm.
wait for the acknowledgement from the other side.
Mm-hmm.
If acknowledgement is not coming, then it will tell session layer, clock starts. C has not
Okay.
responded for this long. Session layer says,
Mm-hmm.
okay, wait, I have some time frame for him to respond. Let me wait for the timeout. Boom,
Mm-hmm.
boom, boom, boom. Okay, I declare page can't be displayed. But nowadays, you still see the page, even though the internet has gone down, it is because of the local buffer. But
Mm-hmm.
if you try refreshing, nothing will come because the internet is,
It's like a cache.
yeah, local cache.
Okay.
But on those days, there was no local cache, so all of a sudden it will say page cannot be displayed. Means
Mm-hmm.
when I say though, that is Stone Age time of the internet. Yeah. So somewhere around 2003 period,
Mm-hmm.
it will simply say
So
page cannot.
cache is locally saved in the wire?
No, 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 no.
No?
Local in your device, in your laptop, in
Oh.
your computer, they come and
Mm-hmm.
accumulate. They get saved, and then it appears in your browser.
Okay.
not on the wire. Wire is not
Okay.
going to keep those data in queue, and it will be a
Uh-huh.
problem for other traffic. Not like, not on the wire.
Okay.
For every service, there is a resource allocation. Process reserve, process is allocated, RAM is allocated, storage is also allocated
Mm-hmm.
for every services. Those are all taken care by your operating system. You might have heard about temp folder, or you
Mm-hmm.
might have
Temporary.
deleted.
Yeah.
See, percentage, temp, percentage. What all these garbages? We have no idea. These are all the temporary files, that is giving you the web page.
Mm-hmm.
So when you access a web page, a lot of files. See, these are all I cannot delete because these are the files that is the reason behind me talking to you now. See, there's a recording
Okay.
going on. Cam recorder
Uh-huh.
is. I cannot delete these things because these things are the buffer, the cache
Mm-hmm. Mm-hmm.
for all those applications that currently running in my laptop.
Okay. Okay.
TCP or UDP is picked up here, and we don't really tell any application use this TCP or use that UDP. It is automatic. It is there in the application that you used to generate the traffic. That application will come and pick the right one, and the service is provided. Now, let's
It's
quickly.
designed in that a way.
Yeah,
The application is designed.
yeah, correct. So the three-way handshake. Let's quickly discuss, and then we'll move on. The TCP is called as connection-oriented, reliable way of communication, um, and UDP is best for delivery. What
Mm-hmm.
does these things mean? These things mean that when A wants to send traffic to B, and if B also want to send traffic to A, both are
Mm-hmm.
willing to send and receive. Now, what happens is, let's say A initiates the conversation first. A will send a sync packet for the synchronization with some random number in it, let's say 432. And then
Mm-hmm.
when B receives it, B is very happy. Just now I was trying to talk to you. Good that you are talking to me now. Let me also say my sync packet is 700. Uh, so this is the challenge I'm sending you. If you respond me correctly, then I know that you are talking, you are ready to talk to me. But anyhow, you are willing to talk to me. I am ready. See to as a token, I'm saying 433 as an
Mm-hmm.
acknowledgement.
Okay.
So when A receives 433, it understands. Aha, B is glad to hear from me, is ready to
Mm-hmm.
hear from me. But still, B is not happy. It's still waiting for A. A now comes and says, good news, I'm also very happy to talk to you. Uh, this is what we call as three-way handshake. Now,
Mm-hmm.
A is very clear that B is ready to do conversation with me, and B is
Mm-hmm.
also uh, happy because it knows that A is ready to talk to B from
Mm-hmm.
the acknowledgement. Only after this three-way handshake, whether you are telnet request or if it is HTTP request, all these things will go. First
Mm-hmm.
is they do three-way handshake before the
Mm-hmm.
actual packet.
Mm-hmm.
If it is
Okay.
telnet packet, before it sends a telnet request to the
Mm-hmm.
destination, it will say, wait a minute, let me first go and see whether he is ready to respond us.
Mm-hmm.
It does the three-way handshake between both. There will be a three-way handshake, and then he sends the telnet request as the fourth packet.
Okay.
This is not seen in UDP. UDP is simply a best effort delivery. Right now, in the session layer, sorry, in the transport layer, our traffic that got segmented, sequenced,
Mm-hmm.
and given a service ID called port number, and then it has picked the TCP or UDP. After this, we
Mm-hmm.
call this data as a segment.
Mm-hmm.
That's a special name given to the traffic that is already past the transport
Okay.
layer.
Mm-hmm.
Now the segment will go to network layer, where it will give a special name called a packet
Mm-hmm.
after giving source and destination IP, and then
Mm-hmm.
after giving the MAC address, source and destination MAC address, the data will be called as frames. And then according to the physical layer, means if I have a Wi-Fi, the physical
Mm-hmm.
layer has got what? The Wi-Fi adapter in my laptop.
Mm-hmm.
So it now transmits the waves out. The
Mm-hmm.
data are going in the form of waves, frequency.
Mm-hmm. Mm-hmm.
If I am connected to a RJ45 Ethernet port, then the physical layer takes the
In
responsibility of
bits.
converting it into bits and bytes, an
Mm-hmm.
electrical signal. So that's the responsibility of physical layer. What is the medium through which I need
Mm-hmm.
to send? How I need to convert it so that the medium will transport it. That's the job of
Mm-hmm.
physical layer. Data link
Okay.
layer provides the unique identification called MAC address,
Mac.
source and destination MAC address. It also got checksum and all. We no need to worry about this. Those things are taken care by operating system. And the
Mm-hmm.
network layer provides the source and destination IP address.
IP
So
address.
in the next class, what we'll do is we'll see how the encapsulation, 7-layer encapsulation happens to a data on the
Mm-hmm.
sending side, and how
So
the
there is no element of routers switches or anything up to transport layer.
no.
Okay.
Uh, I'll come to that point in a few minutes. Let me finish this. So, in our next class,
Okay.
what we are going to see is we are going to see how the data gets encapsulated with all the 7-layer properties,
Mm-hmm.
as I said in the previous class. If you want to make somewhere, there is a procedure what comes first and what comes next. Likewise,
Mm-hmm.
the data needs to be prepared in such a way that it will be acceptable in the network. This is the preparation sequence. Starting from application layer, we need to prepare the data till the physical layer. That's what called as data encapsulation. On the receiving
Okay.
side, on the receiving side, it needs to be a reverse order, and we call this data decapsulation. We will talk about this in the next class. So now answer to your questions. For layer 2, we have switches. For layer 3, we have routers. Is there any device for layer 4, 5, 6, 7? Is that right?
No.
Hmm. Then what's the question?
So we did example for sending between two computers
Hmm.
below there
Hmm.
for the TCP for the transportation example.
Hmm.
So if we have a switch or router in between,
Hmm.
the handshake it still passes from the server to the end device.
Hmm.
So there has to be no like a connection between a router and the end device and a router to the server. No, it just transports the packet.
Hmm. Okay. Uh, so there is a source A here and destination B here, and there's a big internet cloud where thousands of routers and switches are involved, and
Mm-hmm,
A is talking to B,
mm-hmm.
and A talks directly to B. Uh, don't we have any other devices in the middle to which A needs to talk and needs to wait for something like that, correct?
Yeah.
Hmm. Actually, those things are all involved, but When A sends a packet to B, the transport layer is read only by B.
Okay.
Data link
Okay.
layer will be read by switches in the path.
Mm-hmm.
Network layer will be read by the routers in the path.
Mm-hmm.
And they don't have any reason to open the transport layer because the packet is not destined to that middle device.
Okay.
To whomever the packet is destined, they only have the eligibility to
Okay.
open the fourth layer or fifth and sixth, seventh. You got it?
Okay.
Yeah.
Yeah, got it.
So the middle device job is only to do their own job. If I'm a router, I need to route. So how I need to route? First of all, I need to know where he wants to go. Okay, what is your destination, my friend? Okay, it shows the
Mm-hmm.
destination. All right, let me send you. Go this way, this way, this way. Out.
Mm-hmm.
That's it. That's all
Okay.
the job of a router. Likewise, switches based on the MAC
Mm-hmm.
address. They don't really go and read the entire 7 layer of the packet.
Okay.
They're not designed to do that.
Mm-hmm.
But there are devices in the network,
Uh-huh.
even though the packet is not destined to them,
Uh-huh.
they are designed to check from top to bottom very thoroughly,
Mm-hmm.
like an immigration officer.
It's a firewall?
Yes. Some firewalls, they do up
Mm-hmm.
to layer 4. Some
Mm-hmm.
devices, say for example, you are sending a web traffic, you're opening a web page.
Mm-hmm.
WSA is one of the device, web security appliance. It needs to know every bit of that packet
Mm-hmm.
from the application layer to the physical layer, where it is going. Is it
Mm-hmm.
an authorized web page to visit? Is it under the
Mm-hmm.
category of authorized list or blocked list? Why are you going? Who is sending this? It will check
Mm-hmm.
everything and it will decide whether to block it
Mm-hmm.
or forward it. So those devices will do only the inspection.
Mm-hmm.
They're not going to respond.
Okay.
You send a invitation letter to me and I
Mm-hmm.
got the visa and I'm in the immigration. But
Mm-hmm.
immigration can block me at any time. He may
Yes.
say, okay, I can see that you got a letter, invitation letter. Even you got visa, but I don't see you as the right person to fly to that place.
Mm-hmm.
Maybe your health condition is very bad. That country is full of disease. If you go there, you will die. Better don't go. Boom.
Mm-hmm.
I deny your travel.
Mm-hmm.
Instead of stamping me, they cancel it. They can
Yes.
do that. You know that type of thing is possible
Mm-hmm.
in transport and in airlines. If it is possible, going from one country to another country in networking is very easily possible. We have a lot of devices, not just firewall. We have email security appliance, we have web security appliance, we have umbrella, we have Thales, we have many, which will do inspection in the middle. If
Mm-hmm.
someone is sending you a mail, how do you know that this mail uh, uh, is, you will see it will go directly to
Uh-huh.
spam folder. How your browser knows? Because someone in the middle has identified that this is not really a good mail for the user, so let me not send it to inbox, I'll send it to spam, so that only if he voluntarily, if he puts his mouse pointer and clicks it and opens it, he will be seeing this, and there may be a malware which be inside, and it is all in his tip of the finger. He decides to open, let him face it. But I have already categorized it as a spare.
Mhm.
So without inspection in the middle, going from application to presentation, someone cannot do that in the middle. Understand, right? Mm.
Yeah.
All right then. That's all about today's class.